in terms of this quantity. Clear? Now, here m dot Cc is the minimum heat capacity. Now, this term minus UA by m dot C minimum is known as number of transfer unit, NTU, which is a dimensionless term. Overall heat transfer coefficient, surface area of the heat exchanger divided by m dot into C minimum. Now, if you can ask me the questions, you should ask this question to me without gossiping or chatting with your friends at the back. Sir, if the hot fluid is the minimum fluid, what could you have done? Now, if the hot fluid is the minimum fluid, first I tell you, this expression will be same, just m dot C and m dot H will be interchanging with each other, so that in a generic formula I can write in terms of m dot C minimum and m dot C, generic formula. So, this will interchange. If m dot HCH is the minimum, then it will be m dot HCH. NTU is minus UA by m dot C minimum. This will be NTU, and this will be 1 plus m dot C minimum by m dot C. Similarly, it will be 1 plus m dot C minimum by m dot C. But how to do it? Just interchange. Here I will start again. I started with cold fluid as the minimum fluid, hot fluid as the minimum fluid. I will take m dot HCH. This is not all. I will first take. Secondly, I will not TH2, that is the second catch. Here TH2 will not be substituted from this equation, TC2 will be substituted. And in that case, TC1 will not be added, subtracted. TH1 will be added and subtracted. This is having a rhythm. Good boys can understand this thing better immediately by intuition. Here we will take m dot HCH as common. Then it will be 1 plus m dot HCH by m dot CCC. Here TH2 will remain as it is. TC2 will be replaced in terms of other temperatures from here. TH2, TH1 and TC1. And after that I will add and subtract TH1. And in that case I will use the definition of epsilon as TH1 minus TH2 divided by TH1 minus TC1. Because the definition of epsilon is the change of temperature for the minimum fluid and the change of temperature, maximum change of temperature available in the heat exchanger. Now, if you write in a very generic fashion, this will be like this. A generic expression is like this. If I make a very shortcut compact form by defining a parameter, just now if I define it like this, m dot C as the capital C, that means the capacity rate or simply the capacity, and m dot C, m dot CC, CC is the CCC, and m dot HCH is equal to CH. And if I define C as the ratio of C min by C, which may be either this by this, that means this by this, or this by this, depending upon the case. In that case, the expression will be very simple. It looks like simple, expression remains same, 1 minus exponential minus NTU, where NTU is minus UA, sorry, not minus, sorry, NTU is a scalar quantity, dimensionless, m dot C minimum, that means C minimum with this nomenclature, where NTU is NTU into 1 plus capital C, and therefore here it is 1 plus capital C. This is the expression, where capital C is the ratio of the total capacity, that means m dot C, specific heat, ratio of the total capacity. What is the ratio? Minimum to the other one. That means C mean by C. So this is the expression, and this expression is for parallel flow. Counter flow expression will be again a tricky, and that I leave to you to do the counter flow expression. In both the cases, that is left as an exercise, and the expression will be epsilon is equal to 1 minus exponential function of minus NTU into, here it will be 1 minus C, and here it will be 1 minus C into again exponential minus NTU into 1 minus. Now you see that in condensation and boiling, I told one of the fluids will be parallel. In case of condensation, the hot fluid is a parallel line. In case of boiling, the cold fluid is a parallel line. And parallel line means temperature does not change. And I told qualitatively that counter flow and the parallel flow remain same. But now mathematically you see that for a condensation and boiling problem, this one of the fluid specific heat tends to infinity. The fluid which is boiling and the fluid which is condensing, C infinity, I showed you earlier in the figure, which means that C is equal to C mean by C. That means this higher C tends to infinity, because which tends to infinity, that will be always higher. No question of calculation. That means an intelligent boy will tell that for boiling condensation, the ratio which you denote as C will be always 0. And if you put C 0 in both the expression, we will yield the same value. Epsilon is 1 minus exponential minus NTU. This is the argument, NTU. If you put C 0, because the ratio is always 0, because the higher heat capacity rate, whatever we call the product of m dot C, is tending to infinity, which is a hot fluid, cold fluid ka mamla nahi hai. It is not hot fluid, cold fluid. Which one is higher, which one is lower? Okay, clear? But here one thing is very much open, that if I do not know the temperatures explicitly, then what we can do, when we know the NTU, because area we know, overall heat transfer coefficient we know, and the mass flow rate and specific heat we know, we can straight away find out the effectiveness. And when the effectiveness is known, I can find out the temperatures. Clear? So therefore, this is a case where the rating will be done explicitly, no iterations. Rating means the size is given, we have to find out the heat transfer. That means all 4 temperatures are not known explicitly. Clear? Any problem? Okay. So we can find out the epsilon, and say, whenever we find out the epsilon, okay, TH1 and TC1, all right, chalega. Then from the definition of epsilon, I can find out the temperature difference of the minimum fluid. That means heat load aa jayega. The temperature difference of the other fluid will also come. So therefore, where rating heating load and cooling load is not done, but size is given, NTU epsilon method is an explicit method. To find out effectiveness, fatafat temperatures are found. But where the temperatures are given, sizing is to be made. LMTD is useful, because from here, knowing epsilon, NTU as a function of epsilon will be little difficult. You understand? This may require tedious calculations or iterations. So I will take another maximum half an hour to solve 2 problems to make this thing clear. But before that, I will tell you one thing, that before solving a counter flow exchanger, now we will solve 2 problems on heat exchanger, which will demonstrate our understanding of the discussion that which have been made just now in the earlier class. Now the first example is a counterflow heat exchanger of heat transfer area 12.5 meter square. Immediately it should strike that it is not a sizing problem, that means size is given, that means a rating problem. Is to cool oil whose specificity is 2 kilojoule per kg degree Celsius, 2000 joule. It's taken from a book, they have not written in terms of kilojoule, with water whose specificity is 4.17 kilojoule per kg degree Celsius. Now oil is the hot fluid and water is the cold fluid. The oil enters at 100 degrees Celsius. That means in our nomenclature TH1 is 100 degrees Celsius. Here it is written TH in. And the flow rate of the hot fluid, that is oil, is 2 kg per second. While the cold fluid enters, that is TC in, which is in our nomenclature TC1 is 20 degrees Celsius. And the cold fluid flow rate MC is 0.48 kg per second. The overall heat transfer coefficient is given. This will be given for both the cases, rating and sizing problem. 400 watt per meter square degree Celsius. Calculate the exit temperature of water and the total heat transfer rate Q using both LMTD and the epsilon NTU method. Now an idiot will start with the NU epsilon LMTD method, but it is told we have to do it. If nothing is told, so I can start with LMTD. Now you see LMTD, how difficult it is. Now what is m dot h? You tell me. M dot h is 2 kg. What is that? Where it is written 2 kg per second? 2 kg per second, yes. 2 into, what is the specific heat? 2 kilojoule. I am writing in terms of kilojoule, it will be cancelled in. Then TH1 is what? TH1 is, the oil enters 100 minus TH2 equals to what? Water enters 20 degrees Celsius, 0.48. I have to find out Q. Bolo. Good. That is the mistake. I was discussing with these people. I could not rectify, though my teachers told me several times. What is this flow rate? Flow rate is 0.48 into 4.17 diya, no? Into TC2 minus 20. Now LMTD is delta T2 minus delta T1 divided by ln delta T2 by delta T. Now what is delta T2? TH2 minus TC2. Nothing is known. Counterflow TH2 minus TC1 and delta T1 is TH1 minus TC2. Now I cannot find out the LMTD because I don't know this TH2 TC2. So what to do? We assume TC2 or TH2. Let us assume TC2 60 degrees Celsius. Let us assume it will be heated to a temperature, I assume something, it is less than 100 definitely, which may be more than TH2, it cannot be more than TH1. Let us assume 60 degrees. Then I find out this and I find out TH2. So TH2 and TC2 is found out. And I give that one superscript, that is the first iteration. Accordingly, I find out LMTD with the first approximation of this. And when LMTD is found out, these two are known, I found out Q as the first approximation. When Q is found out, I can use this with the unknown TH2 or this with the unknown TC2 and try to match this TH2 TC2 found out with the earlier value. If they are differing, again we put that value and we change this as superscript 2, next iteration, and go, and this loop will go until and unless these two matches. And finally, depending upon your gauge value, if one gives a gauge value by the magic of PC Sarkar 85.6 degrees Celsius, then he does not have to do any iteration. That means he will get a value of TH2 such and LMTD such and accordingly Q, which will exactly match this value. But it is very difficult, only the magician can do. So some iterations will be there. But this problem, if you solve by NTU epsilon method, so therefore we see this is a tedious method. But what is NTU LMTD method? NTU is known. What is NTU? UA C minimum. What is C? 2 into 2, 4. And this is 0.48 into 4. That means which one is minimum? That one, right hand side is minimum. So if you do that minimum, then you find out C minimum, NTU, sorry, NTU is UA by C minimum, yes. Then they find out NTU as AU. U is what? Huh? What is U? What is A? 12.5. And what is C minimum? I just see that multiplication is difficult for me. 2002. That means 2, because this is joule unit has to be there. Because this unit has to be consistent. Here I can write kilojoule because both this side it will be balanced. Be careful with this unit. NTU is a non-dimensional. U is watt per meter square K or meter square degree Celsius. A is meter square. So here C minimum has to be in joule. Don't be that smart to put it here. Finally come with a wrong result. I will be giving 80% marks. If you are happy, then it's all right. So therefore, NTU comes out to be what? Where is NTU? .5. That means if you clear it NTU, then epsilon for a counterflow heat exchanger expression, there if you put NTU, it is an explicit calculation by a small calculator, you can do it, and epsilon comes straightforward. Value of epsilon comes 0.82. Now when epsilon is 0.82, epsilon will be what? Epsilon will be the temperature difference of the minimum fluid, Tc2 minus 20 divided by Th1 minus Tc1. That means maximum temperature 100 minus 20. And this gives Tc2 is equal to 85.6. Explicitly done. So you see that a rating problem is explicitly done by this, but this, that means if anybody else, do you feel that the LMTD method is not at all valid or you cannot do it for the rating problem? No, you can do it, but it is not explicit. And in today's world, both are almost same. By putting into calculator or just making a small program and do it, nothing is there. But it is explicit and there it is implicit by iteration. That is the only difference. Now the next problem. Hey, problem 2. Dekho, this was an interesting problem. Problem 2 is also interesting. Water is heated from 30 to 90. Two temperatures are given. Babre bab. In a counterflow double pipe heat exchanger, water flows at the rate of 1.2 kg per second. That means total load is given. The heating is accomplished by a geothermal fluid which enters the exchanger at 160 degrees Celsius at a mass flow rate of 2 kg per second. That means everything is explicit. We know all the temperatures, the heat transfer. Ho gaya? The heating fluid accomplishes geothermal exchanges at 160 degree and mass flow rate. Everything is given. Because by heat balance we can find out the exit temperature of the geothermal fluid. Okay. Specific heats are not given. No, specific heats are given at the end. The inner tube is thin walled and has a diameter of 15 millimeter. Thin wall, this is an extra language, that means we neglect this wall resistance. It is not required because overall heat transfer coefficient is given. If the overall heat transfer coefficient of the exchanger is 600 watt per meter square degree Celsius, determine the length of the heat exchanger required. Oh, that's why it has given thin, because area has to be found out, then area divided by pi d is the length. That's why the thinness is required, otherwise it will be difficult. The specific heats of water and geothermal fluid as given, use both the LMTD and epsilon. Here, this is the reverse. LMTD is very simple. Epsilon into U star. Why? Because the temperatures are known. Let me write. Very simple. Tell me what you dictate, I will write. Water is 1.2. Or the hot fluid first. Hot fluid is, what is the flow rate? 2, you tell me. 2 into, you tell me, you dictate me, I will write. I will not see the first heat balance. 2 into 4.3, correct? Into 160 minus TH2 is equal to what? 1.2 into 4.18 into 90 minus 30. What is the value of TH2? Nobody can tell without calculating it. So TH2, sorry, this problem, TH2 is 120.10. 120.10 degrees Celsius. Then delta T2, 120, ये क्या हुआ? 125, I'm sorry. 125.10 minus 30 is equal to 95.10. This is meaningless, but still I am doing. Delta T1 is TH1, 160 minus TC2, that is 90. That is equal to 70 degree. With this value, the LMTD will come as 81.91 degrees Celsius. This is the mean temperature, log mean, 81.91 degrees Celsius. Okay. Then A is, Q is U at LMTD, Q by U LMTD, Q by U LMTD, U into LMTD in the denominator. So Q is this one, either this one or this one you put. U is given, what is the value of U? U is 600 watt per meter square degree Celsius and LMTD is 81.91 degree Celsius, which gives A, if you put this value, which gives A as, what is the value of A? 6.12 meter square. 6.12 meter square. And L is equal to A by pi D. And D is given as, diameter is 15 millimeter. We have to put into meter. That means 0.15 meter. And A is meter squared. This finally, it is thin wall. So diameter outer and inner is same. And finally we get L is equal to 129.8. So therefore, this problem is just the reverse. LMTD is straightforward. Clear? Because it is sizing problem. Rating is given. But to do it with epsilon NTU, what you have to do, because here epsilon is known, but NTU has to be found out. Here epsilon is known, NTU has to be found out. In epsilon NTU method, what is epsilon? Epsilon is known. You tell me what is epsilon? Minimum fluid is which one? What is epsilon? Minimum fluid is m dot c dot. This is the minimum fluid. So epsilon will be 90 minus 30 divided by 160 minus 30. So epsilon will be, where they have done epsilon business? Oh, however, leave it. 90 minus 30. This is the minimum. So this is the epsilon. So epsilon becomes what? 0.461. Okay. Now, problem is that epsilon is known. You have to find out what? Surface area and finally length. That means I have to express NTU is a function of epsilon. For that, little more labor you have to put. We expressed epsilon as a function of NTU. You remember that function, if you just write other way, NTU is equal to 1 by C minus 1 into ln, just you do it, epsilon minus 1 divided by epsilon C minus 1. What is C? C is C mean by C. C mean by C. We express epsilon as a function of NTU. Epsilon as a function of NTU. That we expressed. Here I write by rubbing this. If we recall, just now I told that epsilon in a counter flow is what? 1 minus exponential minus NTU into 1 minus capital C, that is the ratio, into 1 minus capital C, again exponential, minus NTU into 1 minus C. So you see, this expression, this capital C is C mean by C. You have to first from here express NTU. This is tough, but it can be done. Sometimes this is not possible to express NTU as a function of epsilon explicitly. Then this problem fails. That means then you have to go for iterations again. But luckily, with a little labor, one can rearrange this function to do that. NTU is this. Now, when epsilon is known 0.46, you just put it and ratio C mean by C max or C you know, and you straightforward find out NTU and find out area. Area will come exactly the same 6.12 meter square and L will be that one which I got 129.87 meters. Now you have been able to appreciate that LMTD method is simple and explicit when we go for sizing. Rating is given, but when the size is given, NTU epsilon method is explicit and simple because we have an explicit relationship of NTU with epsilon, where from epsilon we can find out the rating, which is unknown for this type of problem. So with this I will finish my lecture on heat exchanger. Okay.